is the review for chapter 2. Up on the board so far, there's 4 lessons that were in this. These are the 4 lessons. The first one was what were forces. Second one was Newton's laws. Third is combined forces. The last one is shadows. Okay? None of these should be all that hard, but we're going to go through them real quick. As long as you read the questions and you listen during this, you should do fine. First, it talked about a force. What is a force? Christian.
Force means a push or pull act on the object.
Push or a pull. And I gave examples of pushing a car. Okay, you get behind it, you get 2 or 3 people, good Samaritans, trying to push a car off the road because it stopped in the middle of the road. Okay, that's a push. If you have a wagon, okay, and that was one that they had in here, where if you have a wagon, you put a huge rock in it, and you're trying to take it back to your house or wherever, you have one person in the back pushing, and you have another one in the front with the handle pulling. Both of them, if they're going in the same direction, it's a push and a pull, okay? And that is what force is. Force also has something called direction, okay? So there is direction also, and this is what each force will have. It's going to have the strength or the power that's put with it. It's also going to have a direction. What direction is it going? Okay? Are both forces going in the same direction? Or are they going in opposite directions? This is what's going to tell what's going to happen with it. We moved on. We talked about contact forces and friction. Okay? Contact force. Do you know what that is, Ethan?
It is
What is it?
a force where 2 things touch.
What is it?
It's a force where 2 things touch and causes a force. I know, like that.
Yeah.
Right.
Well, help him, Luke.
A force that requires 2 pieces of matter to touch.
Yes. Got that?
Yeah.
2 pieces of matter touching right there. Friction. What?
Am I supposed to be writing this down?
Yes.
I'm writing just like abbreviations.
What is friction? Emma.
It's a contact force that slows an object down while in motion.
Okay. It prevents it from sliding. The sliding is going to happen, but it's going to depend on the friction that's there. In here on this carpet, if you take your shoes off and you go try and slide, you're not going to go very far because the friction is strong in here. You go outside in the hallway where there's a slick surface, you go and you try sliding, you're going to slide a little bit. We also talked about a slip and slide. You go jump on the slip and slide and you just stick. You put water on it. And you go and you're going to slide. Then we use Johnson's baby shampoo so that if you get soap in your eyes, it doesn't make you cry. No more tears. Yes, Ethan. And if you put that in with the water, oh boy, you'll go nowhere with nothing. You'll go a certain distance with water, and with the no more tears, you're going to go flying on farther. Okay? Less and less friction as we go along. Okay? What are non-contact forces?
A force that does not require 2 pieces of matter to touch.
Yes. What would be 2 examples? Austin?
Gravity. And
Help him, Kane.
Gravity and magnetism.
Magnetism.
Oh, I have another one.
Okay.
Electricity.
Electricity too. You guys are out playing basketball. Kane, what's happening out there?
I'm making every shot.
No, you're missing
That's
every
not
shot.
true.
Yes.
All right,
I
now
have
the
to
truth.
rebound
Yes.
everybody's
No,
shot.
I made every
That's
shot
not
yesterday.
true.
Yesterday I was
Yes.
good.
What was happening out there one day that I was talking to you?
Oh yeah. My gravity was way off.
The gravity was way off. You're shooting the ball and you shoot it up. If there was no gravity, it would keep going. But gravity, you're doing it so that gravity will pull it down in. Okay? When you play kickball, you kick the ball in the air. If you're the one that's fielding it, you're trying to get under where you know that gravity's going to pull that ball down to. Same with baseball, except you use a glove. Okay? Football, same thing. You're trying to get underneath where that ball's going to come down. The quarterback is trying to throw it so that gravity will pull it down to his receiver and not the defender. Okay? Then we're going to move on to Newton's laws of motion. These are the greatest things ever invented, right?
They are?
Yes, because if you go to a theme park,
Oh,
No.
it's nothing but Newton's laws of
honestly,
motion.
he already ruined it.
I know. First of all, they talked about acceleration. Contact. Non-contact. What is acceleration? Acceleration. Brian.
How far you went in a certain amount, like how far you went over time.
No. Riley?
When you go fast and when you slow down.
No.
I got it.
Liam?
It's the changing direction of an object.
I got it. I got it. I got it.
Ethan?
A change in motion over time. That's
Oh.
Luke?
Any change of motion.
Christian?
Is it like the speed or direction?
It's any change of motion.
Kane?
It's it's a change in speed of an object in motion. Or direction.
Or direction.
Any change of motion.
You can be yes.
On Quizlet, I had any change. Well, in the science book.
The rate at which the speed or the direction of motion of an object changes over time. Okay? If you are going 30 miles an hour and you keep going 30 miles an hour but you turn, is there acceleration?
Yes.
Yes, because it's changed in direction. Okay? When you leave the parking lot out here, your parents step on the gas. Is that acceleration? When your parents pull out to make a left turn, they make a right turn and then they're wanting to make a U-turn out there and they stop. Is that acceleration?
Yes.
Yes, because we always think of acceleration as stepping on the gas and going faster. But it's not only stepping on the gas and going faster, it's also slowing down. It's a change in speed, whether it's faster or slower. And it's also a change in direction, whether it's right, left, up, down, okay? Any of these different ones, a change in direction. Now, if there is not a change in motion or a change in speed, what is that called? Luke?
Uniform motion.
Uniform motion. In other words, if you get going in your car and you're on Interstate 10, Interstate 10 goes from like
Jacksonville to LA.
to LA. It's like a straight shot. And it's one of these roads, I know it goes through North Florida. And usually, if you take 75, there's billboards all over the place and there's exits for
Yeah.
this city, that city, all this. You get on I-10, you have Jacksonville, you have Tallahassee, and then there's nothing for a while, a long while. And there is nothing out there. It's a straight road too. So if you set it on cruise control, and there's not a whole lot of people on it, usually. You set it on 60 miles an hour, we'll say 70 because that's the speed limit. You got cruise set at 70 and you're going straight. What is that?
It's a uniform motion.
That's uniform motion because you're not turning, you're not going faster or slower. It's just a constant speed going in the same direction. Okay? All right. Moving on. Newton's first law. What is it? You guys know these, I know. You wrote them down, you did a buncey on it.
An object in motion will remain in motion unless acted on by an outside force.
Or
A change in.
An object at rest will stay at rest unless acted upon.
it goes two ways. It goes like what you're saying. If it's in motion, it will stay in motion. Okay, unless an outside force acts on it. Or if it's at rest, if you're sitting there, you're not going to go anywhere unless an outside force acts on you. Take on Ethan again. He's sitting there. I moved him. I'm the outside force that's moved him. Okay? But in other words, he was at rest. I woke him up, moved him. Okay? Sorry about that. It's pick on Ethan Day. Okay. So that's the first law. An object at rest stays at rest. An object in motion stays in motion unless an outside force acts on it. Okay? This is the one where you had car work to do. Not homework, car work.
Where you just sat there.
You sat in the car. You were supposed to close your eyes so that you wouldn't be seeing things and seeing what your parents were going to do. But you would just, and that way, all that you would do is feel. You would feel yourself move this way or that way.
Yeah, that time I just slept in there.
And what is it when you go this way or that way? Or on a roller coaster, you go up or you go down. What is that? It's inertia. That's where your body, there's a tendency for an object to resist change of motion. In other words, if you are sitting outside the school gate, your parents are watching cars go by, they're just sitting there, they step on the gas. First, there's acceleration. What does your body do?
Go way back into the
Goes
seat.
back in the seat because you were at rest and your body was wanting to stay at rest. It's resisting. That's inertia. Then you start going forward and she makes a sharp left turn.
You go to the right.
You go to the right because that was the way your body was going. It's wanting to keep going straight, which would be to the right. Your car is making you go to the left. Okay, the change in motion. So that's the first law. And an object in motion will stay in motion unless an outside force also.
I've already written down all of them.
Okay. Second law. This is real short. Graham.
A force equals mass times acceleration.
Yep. What were the examples they gave in the book?
They did, I'm pretty sure they did a boat where there was a big, humongous cruise ship.
Yeah, they had two boats. One was a huge yacht,
and then one was like a small little fishing boat, and they put
The same.
25 horsepower on the back of each, and the little one went super fast, but the humongous cruise ship went really, really slow.
Yes, and we saw movies and different things where they showed where they had like a cue stick, and they had the force of the cue stick hitting a cue ball, and it
And
went
then a
down and broke
bowling
all the
ball.
balls, and then the other one was a bowling ball, and the bowling ball barely rolled.
And
Okay.
then when it hit the they just
Force equals mass times acceleration. Okay?
Catapult space one.
Yes. Okay? Then we moved on to Newton's third law.
this one is my favorite.
Tell me about it. It's the bumper cars.
For every action, there's an equal and opposite reaction. Let me see.
Every action.
There's an equal and opposite reaction.
This is one that takes in a lot of things. Crime scene investigators, when they get to a car accident, they're looking at it because if one car hits another car, this car will stop, that car will take the motion. I have Newton's cradle, where we take one ball, pull it out, it goes, hits, and one ball goes out the other way. For every action, the one ball, there's an equal and opposite. We did it with 2, and 2 went this way. We did it with 3 of the 5, and that middle one went both ways. Then we did 4, and you would have to where 4 of them go down, 1 stays there, 4 go up. 4 go down, 1 stays there, 4 go up. For every action, there's an equal and opposite reaction. Car accidents, bumper cars, all of these things have that. There was also, I gave you an example, if you were in a canoe or a kayak, and you took a huge rock, and you're just sitting still in the water. Take that huge rock and you throw it forward. The rock goes forward. What do?
You go backwards.
You go backwards. This weekend there was a launch over at Cape Canaveral. They were sending up a thing, I think it was some satellite that's supposed to help Sirius radio customers, satellite for it, or there were some that were going up for some other things too. But in order to get it up there, what do they gotta do?
They have to send it up there, and they have the rocket ship has the boosters that make it go up,
How?
but the boosters push down that make it go way up.
Yes. They're going that way so that the rocket goes up. For every action, there's an equal and opposite reaction. The other one that I've told you about is a balloon. Blow a balloon up, hold it, you let go. Air comes out, and the balloon goes that way, right? And then you got your Mentos one.
Oh yeah.
Got the Mentos, it's gonna shoot up, okay? But that's that. Then we move on to combined forces. With combined forces, we are talking about adding forces. This goes back to the one that I was telling you with the wagon
And the rock in it.
and the huge rock in it. If you have one person pulling at 50 newtons and you got another person pushing at 50 newtons.
It wouldn't go anywhere because they're both.
No,
Wait.
one's pushing, one's pulling. They're both going in the same direction.
Oh,
How much force is going in that direction, Graham?
100 newtons.
100 newtons.
Double
Okay.
force.
If we had a tug of war and both teams were pulling at 100 newtons. Okay, what would we call that? Equal balanced forces. Okay, because you got 100 going this way, 100 going that way. Nothing is going to go anywhere. Now, in the book, they showed you a picture of a guy laying in a hammock. Okay, all relaxed. He had balanced forces. There was gravity that was pulling down, and he had the two ropes for the hammock going up to the tree that were pulling up. They were pulling up at the same as his gravity was pulling down. So when he laid in that hammock, as long as he balanced himself in it, it was what? It was equal or balanced forces. Balanced forces. Okay? Now, another example that I gave you was if you had, and this one is one that happens where people run out of gas on the road, or they pull up to a traffic light and their car cuts out and then it won't start up. The person in the car is going to get out and try and push it off the side of the road. Other people come, they put their hazard lights on so they know that there's something going on up there and they don't get run into. They jump out, they run and help them. Good Samaritans, okay, doing a good deed. So you got one person pushing. All of a sudden you get 2 or 3 more pushing. As long as they're pushing in the same direction, those are combined forces. So instead of it going so slow because one person's pushing, you're all sitting there, come on, buddy, push it a little faster. If you get out and help them, all of a sudden it's going to go faster. They're going to get it off the road. Okay? And that's combined forces. The last one we talked about was a shadow. Okay? What is a shadow? Emma?
A space of partial darkness where the light is blocked.
It's not complete darkness because light will reflect off of other things and hit there. It's like in here. We've got 12 lights in here. You're going to cast a shadow, but you're also going to have lights hitting where the other places are. If you just had one, where if I turn this light on and put my hand up there like we did, okay, it would make a shadow. Now, if I turn this on and put my hand up to the wall, what size is the shadow going to be?
Smaller.
Smaller. If I bring my hand closer to the source, closer to the light,
It's going to be bigger.
it's going to get bigger. Okay? Now, also, other things that affect shadows. You go outside. I know one day when we were coming in from recess out there, I stopped you all, I commended you on playing real nice out there and getting along. But I also told you to point out where the sun was. A lot of you are like, oh, it's up there. You know, it was hard to look at it because it's so bright. But you could see where it was at. And then I said, look at your shadow. You all automatically turned around and looked at your shadow. Now, in the middle of the summer, your shadow is going to be right around you. First part of the day, it's going to come up from the east, set in the west, the sun. So first thing in the morning, the sun is over here. Where's your shadow? All the way across. It's going to be long. As the sun goes up, what happens to your shadow?
It's going to become smaller.
It's going to get shorter, smaller.
The sun's farther away.
Yes. In the movie that we saw about the shadows, they did a time clock where they put down they had a marker, and they said at 8 in the morning, sun's over here, and they drew a line that went to the length of that shadow for it. And then at 9 o'clock, they did another one. And if you notice, each one of those lines that they started drawing was what? Shorter and shorter. And then once they got to noon,
They started getting longer.
it was shortest, and then it started getting longer as the day went on because the sun was going down and the shadow was growing longer and longer. Okay? So you got to remember that. Early in the morning, late in the afternoon, you're going to have your longest shadows. So acceleration is what?
It's the speed of direction that is,
Speed and direction.
I said that.
Oh, I thought you said speed direction.
Speed and direction, that is made over time.
Yes.
Wait, what are we on?
Acceleration.
Oh, yeah.
Change in speed or direction. Okay? Yes.
I have a question about shadows.
Okay.
What if you move your hand left or right? Like if you moved it like this, it said like Pearson realized what if you move it left or right? What would it be like? Would it be big?
From the source.
Yeah, from like your hand. If you move
Okay.
it
If I
left or
have
right.
it up here, I got it straight centered.
Yeah.
Okay. What happens if I move it over here?
You like 2 fingers in it?
Okay. What else would happen over
The
this way?
shadow's gonna go over there.
The shadow's gonna go that way.
Shadow's going to go that way. If I move it this way, shadow's going to go this way.
Okay.
You're just moving the shadow back and forth across there. All right. I know that we like baseball. Mr. Mink does. Okay? If a pitcher has thrown a ball, okay, to the batter, tell me about some contact forces and tell me about some non-contact forces.
When the ball in the
When the ball and the bat hit, that is a
contact.
contact force. Tell me about a non-contact force.
When the ball's flying through the air, I guess. I don't know.
I need to know more about it. Non-contact force, what is it?
Oh, a non-contact force is when, like, nothing, you don't have to move it. Gravity does or something. I don't know.
You just said it.
Gravity does?
Gravity. So if the pitcher's pitching the ball, is it going to stay the same height the whole way through? It's going to drop down because of gravity. That's the non-contact. Okay? The contact is the bat hitting the ball. What else?
It could also be if the batter misses, the catcher catching it.
Yes, could be the catcher catching it, and that's the contact. Okay? Gravity's going to play a part in it.
When the batter hits it, before he runs, he's gonna throw his bat to the side, and gravity will pull it down.
Okay?
When he hits the ball, it's going to go up, and then the fielder's going to try to get under it so he can catch it.
Okay? Also, what happens if it's a windy day when the pitcher's pitching? Right?
It moves toward the if you pitch it if the wind's moving that way, the ball will move that way.
Is that a contact or non-contact force? Because I can't see the wind.
Contact.
Non-contact
force.
I'm just trying to throw you off.
It's
What is it?
contact. It's contact.
It's contact.
Because the wind is touching the ball.
Exactly.
Because the wind is
The
touching
wind is
it.
actually touching it.
Yeah.
Okay? So it is a contact. And I tried to throw you off by saying I can't see the wind. Right?
I knew it was a contact.
You can see things that move in the wind, but you can't see it. But it is a contact. Okay? Now, suppose you go to, they have what are called soapbox derbies. Okay? A soapbox derby is where you build a car. It has no motor in it, no brakes, none of that. It's just a wooden box car. Do you guys ever see the Little Rascals?
Yes.
Do you ever see the Blur?
Yeah.
Yes.
That's their car.
Oh, that.
Oh,
Yeah. The Blur.
I did not know that.
Okay? That's, and they had a race in one of the movies on it, in which they had to build the Blur 2 or whatever, because the bully kids,
Yeah.
they took the Blur and they went to a soapbox derby race where it's a downhill race the whole way. So gravity is pulling them, okay? What's gonna make the car go faster?
If it's heavier, cause
Is it?
Yes.
yeah, if
Because
it,
then,
I know, because the heavier you are, the more the force of gravity is on you, so it'll pull you down for faster if it's heavier.
I was gonna say that, but then I realized it's still really heavy, so it would probably go a little faster, but not much.
Okay.
It would go slower because it's heavier and
How can we make it go faster though?
You could use the engine.
No. Can't use an engine in it.
Pedal.
like say there's like a bowling ball, like you could roll it down and use like your force.
You could pedal.
No.
I don't know what it looks
Wheels.
like.
A car. You're making a car.
Oh, a car?
You're making a boxed car.
So you could pedal.
How are you gonna make it go faster?
Pedal.
Make it so the wheels on the car, whatever's under it, have less friction.
Have less friction.
That's what I think.
Where the wheels are, they're gonna have less friction. Where the wheels, the rod that goes through there has less friction. The more or less friction there is, the faster it's gonna go. If you got some, brakes are basically clamping down on the wheels to stop them from going. If you have a bicycle and you have the hand brakes, okay, if you've ever really looked at it, basically you pull those and these rubber stops hit on the metal frame of your wheel and they'll stop it, okay? If it's raining out or if you went through a water puddle, you better give yourself a little extra time because there's not gonna be as much friction there because you got water on your wheels. So when you clamp on the brakes, it's gonna take you a lot longer. But on a dry day, you clamp down on the brakes and it's gonna stop you. Now, to make the car go faster, you want the wheels to go faster, right? So as long as there is less friction there, okay, it's gonna go faster, okay? That's what you're looking for, is less friction. Things that will cause less friction for it to go, okay? You think about the slip and slide, no water on it, there's a lot of friction. You're not gonna slide at all. But if you go to putting water on, there's gonna be less friction. You put the Johnson & Johnson baby shampoo so you don't get tears in your eyes. Then you're gonna even have less friction. You go a lot farther, faster, okay? And that's the object of it. Words that you need to know for your test. Non-contact force,
Okay.
force,
Okay.
gravity,
Okay.
contact force, acceleration, friction, inertia, balanced, and a shadow,
Okay.
okay? And that's what you need to know for your test. If you have all this down, you look it over tonight, you should do good on your test tomorrow. Okay, Luke?